Consider the scale of a modern skyscraper. You're looking at thousands of tons of steel, glass, and rock permanently suspended in the air. Without intervention, these structures would collapse. Gravity pulls every inch of mass toward the Earth, while wind and rain actively strip away the exterior. A building remains standing because it is a carefully assembled system of materials, each specifically chosen to counteract those exact physical forces. To win this structural war, engineers rely on 5 primary defenders: concrete, aggregates, mortar, roofing, and flooring. Every material acts as a combatant stationed throughout the structure, engineered to block the brutal elements while keeping the interior safe for humans. The most immediate threat to any building is its own weight. To keep from sinking into the earth, a structure requires a foundation capable of resisting extreme downward pressure. For that, builders turn to the heavyweight champion of construction: concrete. The basic recipe starts by mixing cement, water, and fine sand to form a thick, uniform paste. But on its own, that paste lacks true strength. It requires a final, crucial ingredient: aggregates. Aggregates are raw, coarse materials like crushed stone and gravel, heavily mined from rock quarries specifically for construction. When mixed into the wet cement, these jagged stones interlock. As the paste dries and hardens around them, it forms a dense, stable matrix. Without those tiny, invisible stones creating internal friction, a concrete foundation would simply crack under the massive weight of the building above it. As buildings scale upward, raw concrete is no longer enough to support the structure. To span wide gaps and reach the clouds, engineers give the concrete a skeleton. This is stressed concrete. By setting internal steel frameworks inside the molds before the concrete is poured, the resulting pillars gain immense tensile strength. That steel core absorbs the bending forces that would otherwise cause a solid rock beam to snap under heavy loads. For massive loads, builders use pre-stressed concrete. Steel cables run through the concrete and are pulled taut from both ends. By pre-compressing the concrete with these cables, the beam withstands enormous downward pressure over long distances without sagging. This technique allows for large-scale structures, like highway bridges, to carry immense weight across a river with no underlying support. By introducing steel, builders turn heavy, static rock into a dynamic, load-bearing muscle. A massive skeleton is only half the battle. If the individual bricks and blocks that make up the walls separate from each other, the entire structure fails. To secure these smaller pieces, builders use mortar. It relies on a similar recipe of cement, sand, and water, but it intentionally leaves out the large rocky aggregates found in concrete. Without those bulky stones, mortar becomes a smooth, workable paste that can be spread thinly between tightly packed joints. Mortar trades raw load-bearing strength to become the perfect adhesive, locking thousands of loose bricks together into a solid wall. With the core structure locked in place, builders address the final persistent threats: the weather falling from above and the daily human wear and tear from below. Roofs are covered with materials selected for specific environmental jobs. Lightweight aluminum sheeting provides strong coverage. Clay tiles manage rainwater runoff, and concrete layers maximize storm durability. Many residential roofs rely on shingles. Nailing down these thin, overlapping pieces creates a layered shield that forces water to cascade off, preventing leaks. Inside, wooden floorboards are installed to bring warmth and a safe walking surface to a home, adapting to handle heavy human traffic. For other spaces, easy-to-clean tiles are used in kitchens, and rigid stone is laid down for extreme longevity. Roofs and floors act as the building's skin, custom-fitted to endure the natural elements outside while securing a clean, comfortable environment inside. Pulling back from the finished building reveals a meticulously layered system of defense, where every material works in concert to resist the outside environment. From the heavy aggregates stabilizing the foundation to the shingles on the roof, every material was chosen to perform a highly specific physical job. Our homes and workplaces exist because of these engineering choices, which work invisibly to resist gravity and weather every day.